Now we are working on this series. So today we are going to covering UGC NET-DEC December 2019 solved papers. This paper contains 100 questions from electronic sciences. In the first video, first part, we have covered the question number 1 to question number 15, and in next video we have covered 51 to 100. So let's start. The question number first. In a polar junction transistor, the collector current is, and your option first, beta upon alpha IC0 plus beta into alpha IB. Second option, IC0 upon 1 plus beta plus IB upon beta. And third, IC0 upon 1 minus alpha minus IB upon alpha. And fourth option, IC0 upon 1 minus beta plus IB upon alpha. And the right answer is first, that is beta upon alpha IC0 plus beta into IB. And next question, in question number second, in a semiconductor, the concentration of holes in a balanced band can be given as, you can see here the options, and the answer first, and correct answer is first, that is NV into exponential minus EF minus EV upon KT, where EF is the Fermi energy and EV is the balance energy level. And next question, question number 3. For a semiconductor with the electrons and holes as carriers, the resistivity is given as, and you can see here the options, and our correct answer is option second. Is the second, that is 1 upon Q into mu n dot n plus mu p dot p. Question number 4. The band gap energy for silicon depends on the temperature T and can be described as, and EZ of T is equal to 1.21 minus 3.680 into 10 to the power minus 4 Tesla is the correct option. And next, question number 5. The depletion layer width at the thermal equilibrium for one-sided abrupt p-n junction diode where NB is equal to ND or NA is, option you can first option first, root 2 epsilon s v VBI upon QNB. Second option, root QNB upon 2 epsilon s VBI. Third option, root epsilon s VBI upon 2 QNB. And fourth option, 2 epsilon s VBI upon QNB whole of square. So your correct answer is first, that is root 2 epsilon s VBI upon Q and B. Question number 6. The one-dimensional Poisson equation for the surface space charge region at the drain is. This is a simple theoretical question, and your answer is, your correct option is third, that is del square psi upon del x square is equal to minus q upon epsilon s into nd plus minus na minus plus p minus n, where nd is the number of donors in a positive and na number of acceptors with minus and that the p is the protein holes and n is the electrons. So next, now question number 7. The pull up to pull down ratio for NMOS metal oxide semiconductor inverter driven by another NMOS inverter is, and the correct option is second, that is minus v dt square upon v inverse minus vt whole square. That is question number 8. If D0 is the frequency factor, E is the activation energy, T is the temperature, and K is the Boltzmann constant, then the diffusivity determined over a range of diffusion temperature can be expressed as, and you can as, and your option is first, D0 into exponential E minus E upon KT. Second option, D0 exponential minus KT upon E. Third option, KT upon Q into exponential D0 upon E. And fourth option, D0 into exponential KT upon Q. And the correct option is first, that is D0 into exponential minus E upon KT. Next, Question number 9. The process which offers the possibility of growing high quality oxides at temperatures even lower than those achieved with the high pressure technique is. And your option: wet oxidation, dry oxidation, anionic plasma oxidation, and axial dry oxidation. And your correct answer is option third, anionic plasma oxidation. Next question, question number 10. During the crystal growth, if A is a constant, EA is the activation energy, T is the absolute temperature, and K is the Boltzmann constant, then the concentration of point defects can be expressed as. And option A, option first, A exponential KT on EA. Second option, A into exponential minus EA upon KT. Third option, exponential KT upon A into EA. Option number 4, A exponential minus KT upon EA. And your correct answer, option second, that is A exponential minus EA upon KT. This is simple, theoretical, one line questions. So next, question number 11. For the periodic signal f of t satisfying declared condition, then the Fourier series consists of option A, sine and cosine terms, the option B is second, DC sine and cosine terms, option third, DC and cosine terms, and option 4, only cosine terms. And your correct option is second, that is DC sine and cosine terms. Now next, question number 12. Destination in time algorithm is the class of option A, discrete Fourier transform, option second, Z transform, option third, Laplace transform, and option 4, fast Fourier transform. And your correct answer, option 4, fast Fourier transform. Next question, question number 13. You can see a Laplace question, the Laplace transform of the wave as shown in the figure. You can see the figure, frequency on the y-axis, along y-axis, and the time period along the x-axis. So in this case, you can solve very simply, taken as the coordinate point from here 0 0 and here as let something here 2 and then this here. So you can get in the right equation, and it's also equation, write down this equation and you can simply transform. So you can see here the options, and the correct option is second, that is 2 upon ts square minus 4 ts square into e power e minus ts by 2 plus 2 upon ts square into e power minus ts. And next question, question number 14. The symmetry property of the discrete Fourier transform d at t is, and you can see here the options, and your correct option is first, x bar of n d of t x bar minus k and is the condition 0 less than equal n less than equal capital N minus 1. And next answer, which one of the following option gives the correct relation of the center frequency f out and log range f of L of PLL phase log loop? And correct option, option number 4, f out nearly equal to 1.2 upon 4 R1 C1 into Hz, and f of L is equal to plus minus 8 f out upon V Hertz. Next, question number 60, simple the waveform as shown in the figure and the correct expression of the waveform. So simply you can write here the coordinate point, that is 2 2, and here 0 1 0, and write the equation, and again this write the equation of this line and combine both and write the simple Laplace transform, and that the correct option is 4, that is s of t is equal to 2 into t minus 1 ut minus 1 minus 2 into t minus 2 ut minus 2 minus 2 ut minus 2. Next question, question number 17. The amount of ripple in output voltage V0 of the frequency to a voltage converter is, on option first, option 1, correctly proportional to the value of integrating capacitor and the frequency of the input. Option second, inversely proportional to the value of integrating capacitor and the frequency of the input. Option third, independent of the value of integrating capacitor and also independent of frequency of input. Option 4, independent of frequency of input but directly proportional to the value of integrating capacitor. So, your correct option second, that is that is the amount of ripple in the output voltage of frequency to the voltage converter is inversely proportional to the value of integrating capacitor and the frequency of the inputs. Next, question number 18. The input impedance of a transistor with an emitter resistor in an emitter bias configuration is given. That is correct option. Option third, Z input is equal to beta Re plus 1 beta Re plus beta plus 1 into Re. The next question, question number 19. If Rs is the source resistance, the output resistance of emitter follower circuit using the simplified hybrid model would be, and the option first, 1 upon HOE, second option HIE plus 1 upon RS upon HFE, third option RS plus 1 upon HOE, fourth option HIE plus RS upon 1 plus HFE, and the correct option is fourth, that is HIE plus RS upon 1 plus HFE. Next question, question number 20. In N-channel enhancement type MOSFET, as VGS is increased beyond threshold level, and your option A, first, drain current will decrease. Second, density of free carriers in induced channel will remain constant. Option third, density of free carriers in induced channel will decrease. And option fourth, density of free carriers in induced channel will increase. So correct option is fourth, that is in N-channel enhancement type MOSFET, as VGS is increased beyond threshold level, the density of free carriers in induced channel will increase. Next question, question number 21. Solve the following Boolean expression. Very simple. Expression y equal to a into a naught plus c into a naught b plus c into a naught bc plus c naught, and select the correct option. So simply you can solve it directly to open all, and you get the correct option is first, that is 0. Next question. Question number 22. A PROM can be made using option A. First, a fixed AND array and programmable OR array. Option second, a programmable AND array and fixed OR array. Third, a programmable AND array and programmable OR array. And fourth, a fixed AND array and a fixed OR array. And the correct option is first, that is a PROM can be made using a fixed AND array and a programmable OR array. Next, question number 23. A divide by a 50 counter can be realized by using option first, 5 number of mod 10 counter, option second, 10 numbers of mod 5 counter, option third, 1 mod 5 counter followed by 1 mod 10 counter, option 4, 10 numbers of mod 10 counter. Correct option is third, that is a divide by 50 counter can be realized by using a 1 mod 5 counter followed by 1 mod 10 counter. Next question, question number 24. A figure of merit of logic family is given by the product of option first, gain and bandwidth, second, propagation delay and power dissipation, third, fan out and propagation delay time, fourth, noise margin and power dissipation. Correct option second. That means the figure of merit of logic family is given by the product of propagation delay and power dissipation. Next question, question number 25. Find the function represented by the following circuit. You can see here the circuits. These are the AND gates, these are OR gates, and all are coming on in AND gate, and then you get the output. So simply, when you applied the A and B and you're getting the output on point U, A dot P, A into B, and when it's applied again in OR gate, then you get A plus A dot B equal to X. Similarly, at point Y, you get B plus B dot C, and at point Z, you get C plus A dot B, and all is going to through the AND gate, and you get the output and the correct after a big expression, and then you can solve, you get the AB. Next question. Question number 26. In 8086 microprocessor, if DX 1100H, BX 0200H, and SI 0500H, the address accessed by MOVCH plus SI is first 00300H, second 11700H, third 0700H, and fourth 01800H. Correct option is second 11700H. Next question. Question number 27. What is the value of register A at the end of program given below? MOVA hashtag 36H, RRA, and option first 01100011, option second 11000110, option third 100011101, option fourth 00110001, and correct option second 11000110. Okay. Next question. Question number 28. What will be the status of CY, AC, and P flags after implementation of following sets of instructions in 8051 microcontroller? MOVA hashtag CCH, ADD A hashtag A9H. Our option CY1 is C1P0, second option CY1 is C0P0, third option CY1 is C1P1, and fourth option CY equal to 0, AC equal to 1, and P equal to 1, and the correct option is third, that is CY equal to 1, AC equal to 1, P and P equal to 1. And next question, question number 29. In 8051 microcontroller, which register is used slowly for serial communication? And your option TMO tommed, second SCON, third ASBOOF, fourth PCON, and the correct option third ASBOOF. And the next question, question number 30. Which register bank of 8051 microcontroller is used after implementing the following instruction? SETB PSW.4, and option first bank 0, option second bank 1, option third bank 3, and option fourth bank 2, and correct option is fourth, that is bank 2. Next question, question number 31. What is the absolute potential at a point P which is 2 meters from a point charge Q plus 5 microcoulomb, and the work required to move a plus 8 nanocoulomb charge from infinity to point P? Assume epsilon r equal to 1, and the correct option is fourth, that is 22.5 kilovolt and 180 microjoule. Next question. Question number 32. If the Poynting vector or a power density of TIM waves, that is transmitted in electromagnetic wave, 79.6 Weber per meter square in a lossless medium, epsilon sigma equal to 0 with epsilon r is equal to 4, then the magnitude of electric field is, correct option is 122.5 volt per meter. And next question 33, that is evaluate the radiation resistance of hydrogen dipole as a radiating element having length r is equal to 1 meter at f frequency 330 megahertz with the uniform current distribution. And you can option 9 ohm, 10 ohm, third, first 5 ohm and 8 ohm. Your correct answer is 8 ohm. Next question, question number 34. The field around an antenna may be divided into the two principal regions, Fresnel zone and Fraunhofer zone. If L is the maximum dimension of antenna and lambda is the wavelength, then the radius of Fresnel-Fraunhofer boundary sphere is, and your correct option first r equal to L square upon 2 lambda, second option r is equal to L upon 2 lambda, third option r equal to 2L square upon lambda, and fourth option r is equal to 2L upon lambda square, and the correct answer is third, r equal to 2L square upon lambda. Next question, question number 35. Standing wave envelope for reflecting wave is equal to half the incident wave amplitude, ER is equal to 0.5 AI. The voltage standing wave ratio VSWR of the wave shall be option first 1 upon 3, second option second 2, option third 3, option fourth 1 by 2, and the correct option third, that is 3. The figure of merit in the SDSS system is option first 0.5, option second 1, option third mu square upon 2 plus mu square, and option 4 is 2, and the correct option is second, that is 1. Next question, question number 37. The frequency range of satellite communication is option first 1 kilohertz to 100 kilohertz, option second 100 kilohertz to 1 megahertz, option third 10 megahertz to 30 megahertz, option fourth 1 gigahertz to 30 gigahertz. Now correct answer is fourth 1 gigahertz to 30 gigahertz. Next question 38. The cladding which surrounds the optical fiber core. Option first is used to reduce the optical interference. The option second is used to protect the fiber. Option third acts to help guide the light in the core. Option 4 ensure that the refractive index remains constant. And correct option is third, that is the cladding which surrounds the optical fiber core acts to help guide the light in the core. Next question, question number 39. A binary data sequence 11001110 is applied to a 16 array PSK modulator system for transmission. The bit duration is 1 microsecond. The transmission bandwidth of 60 array PSK is option first 1 megahertz, option second 0.67 megahertz, option third 0.5 megahertz, option 4 0.37 megahertz. Correct option third 0.5 megahertz. Next question, question number 40. A TDM link has 424 signal and each signal is sampled 8,000 times per second. Each sample is represented by 8 binary bits and it contains an additional bit for synchronization. The total bit rate made from the TDM link is, and your option first 1600 kilobits per second, option second 1728 kilobits per second, option third 1826 kilobits per second, and option fourth 2056 kilobits per second. Option correct option second, that is 1728 kilobits per second. Next question, question number 41. For the system C of S upon R of S equal to 16 upon S square plus 8S plus 60. The nature of the time response will be option first overdamped, option second underdamped, option third critically damped, and option fourth steady. The correct answer is option third, that is critically damped. It's simply shown in equation and you can solve it. So next question number 42. Choose the statement which is incorrect. Statement first. The speed of a DC motor can be varied by controlling armature voltage. Statement B. Second, the speed of a DC motor can be varied by controlling the field current. The speed of a DC motor can be varied by controlling the armature current, that is the measure of the type 2 demand. And option 4, for a speed more than statement 4, for a speed more than the base speed of DC motor, the armature and voltage is varied to control the speed, while armature and field currents are maintained constant. And your correct option, that is 4, that is your statement is incorrect, that is 4, that is for a speed more than the base speed of DC motor, the armature voltage is varied to control the speed, while armature and field currents are maintained constant. Is incorrect. Next question. Question number 43. The open loop transfer function of a unity feedback control system is given below. G of s is equal to k upon ss plus 1 into s plus 3. The system has option first 1 breakaway point, option second 2 breakaway points, option third 3 breakaway points, option 4 0 breakaway points, and correct option first 1 breakaway point. The next question, question number 44. The transfer function is given below. C of s upon r of s is equal to 2s plus 5 upon s square s power 5 s power 5 plus 1.5 s4 plus 2s cube plus 4s square plus 5s plus 10. The number of the roots with positive real part is, and your option first 0, option second 1, option third 2, option fourth 3, and the correct option is option third, that is 2. Next question, question number 45. SCR di over dt protection is done by which of the following methods? Option first, number circuit in parallel to SCR. Option second, trigger circuit at a gate terminal. Option third, by using the communication circuit. And option four, connecting induction in series to SCR. And correct answer is option 4, that is connecting induction in series to SCR. Next question, question number 46. In Yamuna Bridge, the dissipation factor of a series RC circuit is defined as option first, cosine of phase angle, option second, tangent of phase angle, option third, cotangent of phase angle, and option 4, sine of phase angle. And the right answer is option third, that is cotangent of the phase angle. Next question, question number 47. In a crossed coil power factor meter, the moving coil should be mounted on which type of shaft and at what angle to each other? Option first, different shafts and right angle. Option second, same shaft and right angle. Option third, different shafts and 45-degree angle. And option fourth, same shaft and 45-degree angle. Correct option, option second, that is same shaft and right angle. Next question, question number 48. A 500 kHz waveform is to be displayed by digital storage oscilloscope DSO that samples at a rate of the 50 megasecond per second, 50 mega samples per second. The number of samples taken during 1 second. Option first 10,000, option second 1,000, option third 0.01, and option 4 100. Correct option is option 4, that is 100. Next question, question number 49. Velocity transducers essentially consists of one of the following. Option first, moving coil fixed in the magnetic field of the permanent magnet. Option second, moving coil suspended in the magnetic field of a permanent magnet. Option third, stationary coil fixed in the magnetic field of a supermagnet. And option fourth, stationary coil fixed in a force balancing servo system. Our correct option, option second, that is moving coil suspended in the magnetic field of a permanent magnet. Next question, question number 50. Which of the following expression is correct formula of deflection sensitivity S of a cathode ray tube CRT. If D is a deflection on fluorescent skin, L is the distance from center of deflection plate, ID LD effective length of the deflection plate, and D small d distance between the deflection plates, ED deflection voltage, EA oscillation voltage. And your correct answer is option number 4, that is S equal to sensitivity equals to L into LD upon 2D EA. And next, thanks